Evening, and thank you for joining us tonight online and in person for our presentation that kicks off the fourth Sustainability Speaker Series. My name is Mike Noreen, and I am representing one of the sponsors tonight, Hope for Earth. Hope for Earth is a local nonprofit, and our mission is to create a hopeful, ecologically sustainable future for River Falls through collaboration, education, partnering, advocacy, and action. And I want to thank the River Falls Public Library for hosting and sponsoring this event as well. And tonight, you're all here to see Sven. Very excited to have you here. Sven's going to present on the Northern Arctic connections. Sven has led groups to the Arctic and the subarctic from Svalbard to Hudson Bay and conducted lectures in Churchill Northern Studies Center on climate conditions affecting polar bears. He's also observed about 60 of the largest predators on land in different ice conditions in different years. The polar bear in the Arctic, like the moose in Minnesota, offers insights into the changing climate conditions on our iconic species. Let's explore some of the latest climate trends in polar bears and in our North Woods. Sven's been a meteorologist for more than 2 decades, most of which has been spent broadcasting in Minnesota and a little bit in Duluth. He's currently a meteorologist for Minnesota Public Radio and digital news information platform and bringmethenews.com. He also provides weather and climate content for other organizations and is a scientific advisor for the Minneapolis Foundation. Please welcome Sven Sundgaard.
See if I want to keep track of time here so that I can talk forever. So this is the first time I'm doing this in like a 45-minute talk where I'm going to try to tie, because polar bears are the mascot of climate change. Everybody knows that. But what I think is interesting for our more regional perspective is that the moose is our sort of ambassador. I think they wander through northern Wisconsin. They maybe don't have permanent residency there like they do in northeastern Minnesota, but icon of the North Woods. And both the western Hudson Bay polar bears and moose in the North Woods live on the edge of where they can really exist. Moose are deep into Canada and Alaska, and they're not going extinct anytime soon. They'll have plenty of cold weather and ecology there, but it's those fringe areas, places like northeastern Minnesota, northern Wisconsin, the UP, that southern extent that is changing rapidly. And when that area disappears, you lose those species with it. And polar bears too, people are sometimes surprised to learn polar bears aren't going extinct at the end of the century. There's been a lot of gloom and doom, and they are definitely threatened. But where they will probably not be at the end of the century is Churchill, Manitoba, which is considered the polar bear capital of the world. So for the polar bear capital of the world to no longer have polar bears in 2100 is still a really big deal. And eventually there won't be suitable habitat to maintain certainly the 20 different population groups of polar bears in the Arctic. But I want to start because what is it, September 26th? Yeah. 5 days from October, and we still are having to say, is it hot enough for you? Right? How have you liked August part 2? I mean, it's hard to complain if you like summer. I love summer, but it's not good for everything. But September is one of our fastest warming months in the year. Over just 50 years, we've warmed a full 5 degrees. And when we look at actual degrees of change per decade, the winter months are warming the fastest, but when we standardize those anomalies, and if you're not a stats person, I'll try to do this in a real quick way, but you take the anomalies and divide it by the variability or the standard deviation so that you're comparing apples to apples and not apples to oranges, because winter you have a lot more variability. A 10-degree temperature swing in January is not the same as in August when we have the least amount of variability in the year. So it allows us to compare them all on the same scale. And then September has the fastest pace of warming of any month in terms of its standard deviation or variability. So fall warming is a big thing. June and September are really fast warming months. So what's interesting, July and August, our hottest times of the year, aren't getting hotter. In fact, July is almost flatlined over a century, but summer's starting earlier and ending later. So summers are getting a lot longer, whereas pretty much all months of the winter are warming. Although it is interesting that February, April, May are the only 3 months that are flat or slightly cooling. And that I could do a whole nother hour talk on that. And we're going to summarize it a little bit. But September, we're going to close out the warmest September on record across the entire states of Minnesota, Wisconsin, and specifically the Twin Cities. Easily. And we're blowing the number one spot out of the water, kind of. And the number one spot was last September, which is crazy. And that's what's so crazy about this last winter we got through. Normally when we're comparing seasons or monthly averages, number 3, 2, 1 are all a few tenths of a degree between each other. And this winter was like 1.5 degrees from the previous number one spot. And this September beat last September, or will, by almost a whole degree. That's a huge amount. This September's temperatures literally averaged out to be what a normal August is. So that's why I'm not exaggerating. This September has actually averaged out to be what August should. And so what was once probably a generational kind of warm September now becomes once a decade. And this is how shifting those averages when we're talking about warming in a climate makes those extremes much more frequent and much more probable. I promise the people who don't know stats, no more stats. I guess I lied. But so everybody knows the bell curve though, right? When we lay out all our temperature data, it forms a bell. And the average is, when you move the average a couple degrees, nobody really notices. But what you exponentially do is shift the extremes. You lob off the cold extremes and exponentially increase the hotter extremes. And so when we talk about, Minnesota and Wisconsin's warmed 2 degrees over the last 50 years, and you're like, oh, okay, that's whatever. What's the difference between 48 and 50? Well, it's a huge difference. That's a whole standard deviation of the data. So moving a big chunk of that bell to the right. Fall, as I mentioned, is a warming period too as a whole. So I showed you September, but fall itself has warmed pretty dramatically, 3.8 degrees over the last 50 years. Standard deviation, again, is just 2.6. And what's really interesting about this September is these are wind roses. And this tells you a lot. You can look at the temperatures, but if you look at even just the winds, does this have a laser? Oh, it does. I keep wanting to do that. And then I'm like, well, does it work? There it goes. So this is what a normal September's wind profile should look like. So a wind rose is the magnitude of the wind speed, but also the direction. And you can see a typical September should be a struggle between southeast winds and northwest winds, right? Those are the falls we grew up with. Warm, cold, and then eventually it's just cold, right? But then look at this September. Hardly any winds from the colder direction, all southeast winds. Did I go too far? Oh, okay. And when we look at our year as a whole, here's January on the left and then July on the right. So I chose our coldest and warmest times of the year to show you that July really is a mix historically of warmer days, cooler days, i.e. northwest breezes or south winds, that back and forth. Obviously, it's not cold in July, but we used to get more frequent breaks from the heat in July and August. So that's one thing that we're seeing is the consistent above 80 degrees instead of, a day or two in the 70s and then it's 90 and then a day or two in the 70s. That doesn't happen as frequently anymore. And so a typical July should have that back and forth. But look at January. Oops. There we go. Maybe don't use the laser. I do. Okay. I'm not going to. But look at January. What wind direction dominates a normal January? Northwest. And what's to the northwest of us? The Arctic. So what happens in the Arctic doesn't just stay there. So when you hear about, they're worried about there not being any ice at the end of the summer, and you're like, well, what does that have to do with everybody else? Well, the Arctic, especially in the Northern Hemisphere, is our AC unit. Without the AC, it's not going to be very fun. And the Arctic just had its annual minimum. So we measure the minimum and the maximum so that we can compare years. And at the end of the Arctic summer, in September sometime is when the Arctic has its minimum amount of ice. After the long Arctic summer, melting, what do we have left at the end of the summer? And you can see how it's changed since 1980. We have about half as much ice at the end of the summer now than we did just 44 years ago. And 2024 just ended up being the seventh lowest minimum sea ice. 2012, which is the orange dot towards the bottom there, still stands as the minimum for now, but it's only a matter of time before we break that, of course. And this is what it looks like comparison wise. On the right is what the minimum looked like this year, so you can see where the ice was, and then compare that to the average in the 80s. So you can see that almost half as much ice just in that short amount of time. And the reason that matters is we all know that if you put ice in a drink, it cools it off, right? But if you put that drink in the freezer, which glass of water is going to freeze quicker? The one that has ice in it already or the one that doesn't? Right? And so less and less ice means it's harder and harder to freeze that water. It's going to take longer. It's going to take more energy. And then this is Arctic ice by decades. And this is a really cool map because it really demonstrates when you lay out the averages for each decade, how much less and less ice we have since the 1980s. The other thing ice does that's not as obvious, maybe, ice keeps your drink cold, but snow and ice, even dirty ice that's been there all spring and summer in the Arctic, reflects back almost 90% of the sun's light. Whereas open water, the water can be 34 degrees, but it's a dark surface. It's absorbing sunlight, 90% absorption. So we get this feedback loop of melting sea ice because the climate's warmer. But when we do that, we lower the albedo, or we absorb more sunlight because there's less reflection. And then that increases the heating. So you see, you get into this loop where things just kind of run away. So you have even more unintended consequences down the road. And all of that affects our climate, as we saw for much of the year. Our wind is coming from there half the time. That's what keeps Minnesota. Minnesota is the Arctic, and Wisconsin and the whole upper Midwest. And this Arctic amplification really is noticeable once we hit the 80s and 90s, whereas global warming was on par with the Arctic's warming too, but then with less and less ice, you get this exponential warming, so that now the Arctic is warming at almost 4 times the global rate on an annual basis. And that affects us in terms of, remember I talked about how February and April are 2 months that are actually getting slightly cooler? Well, we're getting more of these polar vortex disruptions where they used to be less frequent. The theory is because the jet stream is weaker. On the upper left is when we have a normal cold Arctic. Big temperature contrast, that's what drives the jet stream. But when you weaken that temperature contrast because you're warming the Arctic faster than the rest of the planet, you get a more wobbly jet stream because the wind is weaker. So we get stuck into these extreme patterns. And the most likely time for that to happen for us is at the end of the winter, when that cold, the last of the cold, is dying and doesn't know where to go. Normally it stays kind of spinning and slowly dying over the Arctic. But increasingly what's happening, not every year, but every few years, as recently as 21 or 2022, we had one of these polar vortex Aprils where it's just cold and snowy, and it compares to times of 100 years ago, and people are like, oh, so much for global warming. Yeah, because it snowed on April 20th does not mean that global warming is canceled. But we get stuck into these patterns that it's easier for that cold to get lodged into the upper Midwest. You can kind of see that in the upper or that lower right paragraph or graphic, and then on either side it pushes warmth farther north than it should be. So you've heard probably in the last few years that we get these like 40-degree readings deep into the Arctic in February when it's still dark there, and everyone's like, what the hell, how's that happening? Once you get into these extreme jet stream patterns that allow, so when Texas had that deep freeze, when was that? 5 years ago now? 3? At the same time, super warm air was surging deep into the Arctic. And so again, to go back to this, because I'm going to give you a couple more examples, and this is an example I made specifically for the River Falls area, which obviously it gets colder on a winter night than where I come from on the urban heat island of Minneapolis. So for the Twin Cities, 33 below zero is pretty much an impossible number to reach now. We've warmed that much, combination of climate change and an urban heat island, that's not even possible anymore. But for you guys, this is an extreme value that I chose that used to be a century ago about a once in a 5-year occurrence. So it's not every winter that you hit 33 below, but it happened every so many years where it wasn't a total like, oh my God, what is this? You know, it did happen occasionally. But now with the warming we've already done, it's only a once in 11-year event. So now it's once a decade. Half is likely to happen. And with future warming, it might only be a once in a lifetime or generational event, 1 in 45 years. And that's just with 1 degree of warming and another degree of warming. So to go back to that graphic, little changes in the average have exponential shifts in the cold and hot extremes. This winter, which was an insane winter, warmest by far, and I talk about, again, we're talking about a few tenths of a degree, usually between top rankings. This one was literally off the charts. It's already now, so people keep asking, oh my God, is this the new normal? Is it here, or is there nothing we can do anymore? And I'm like, no, this isn't the new normal. It was the collision of extremes. Things are always going to happen. Weather, El Nino and La Nina are normal weather patterns that happen on and off, but climate supercharged everything so that it created this winter. This winter could not have happened without the warming that we've done. So, but even with that said, even with the warming we've already done, it's a once in a 70-year event probably. So most of us probably won't see another winter like last winter, unless we keep warming the planet at a rate that we are. But historically, and this is how we can do these rapid retribution studies where we can see what's the role of climate change. And statistically, we can say with the warming we've done in the winters over the last century, that historically that would have been a once in a 500-year winter. So again, not impossible. You hear people say, oh, but it was hot in the 1930s. Yeah, you're always going to have hot and cold extremes, but you're increasing the frequency of certain things by altering the average. So what was an event that we probably had a winter sometime in the last 5,000 years in the region that was as warm as this last one, but it should only be a once in a 500-year event. Now we've made it a once in a 70-year event. And in the future, by the end of the century, again, not the new normal yet, but it could be a once in a 5-year thing. If we have a winter like this last winter that's every 5 years, this is not at all the recognizable climate of Minnesota or Wisconsin. We become Missouri or northern Arkansas. I don't want that, do you? No offense if anybody's from Missouri or Arkansas, but I hear the Ozarks are nice. But yeah, with a further 7 degrees of potential warming, which is how much we've already warmed our winters, this winter will be made 14 times more likely. So it's that turning the dials, increasing the probabilities by just shifting what are pretty small values. Oh, I'm making good time. Okay. And that brings me to why the cover slide, I had a moose and a polar bear, which actually will come across each other, by the way, in the Churchill area. It's a unique spot where you have a few major biomes meeting in one spot, which should remind you of where we all live. Minnesota and Wisconsin, where you have the prairie, the deciduous and coniferous forests all merging in one area. Really unique areas that have unique ecosystems and climates. But again, if you're living on those edges of that environment, you're the most at risk to the changes that we're seeing in terms of climate change or any variety of other threats. But the Churchill area, so I've circled both the North Woods area of northern Wisconsin, Minnesota, where the moose are, and then the bigger circle, the western Hudson Bay polar bear population, both areas that are on the edge of their biomes. And this map shows areas that are most vulnerable to change in red. And you can see northern Minnesota, northern Wisconsin, even parts of southern Minnesota, western Wisconsin, and then a strip of the edge of the subarctic tundra there in Canada, because all those areas are already starting to shift northward. So that's where they all are kind of related. And what's interesting is we don't have many of our big animals left, what are called megafauna. Moose is the biggest animal by far in Minnesota, Wisconsin, our biggest mammal. And the polar bear is the biggest land predator. And so that's, and we've got mountain lions and some other, herbivores, but we have a fraction of the megafauna we used to before humans arrived in North America. Africa still has the highest numbers. That's why we all pay big money to go to Africa, right? You can actually see elephants and rhinos. There was rhino species in North America. We had our own elephants here. We had our own giant sloths and crazy things. And humans overlapped with them. Wouldn't that be weird? Can you imagine? And I'm not going to talk about rhinos. I could talk about rhinos on my own too. But Jeff Montefiore is from Sartell, Minnesota, and he has worked with Save the Rhino Trust in Namibia, southwestern Africa, for 20 years. And they have this really successful anti-poaching program, which again is a whole story in itself. But they have, whereas in South Africa, it's a bloodbath. You have multiple rhinos a day being killed for their horn. In Namibia, it's like 2 or 3 a year. All because of this really great program. But the last couple of years, they've had these extreme droughts. This is an arid place. This is like in Arizona. It's supposed to be dry, but they get into these even drier periods or droughts. And he's been saying the last several years, they're losing more rhinos there to climate change than to poaching, because the calves aren't going to survive, or you're not going to have successful pregnancies. And the older rhinos obviously aren't going to make it either. And this is the historical black rhino range in orange, and then circled in about 20 different little red pockets are all that's left of the black rhino today. And the star I put in Namibia is where this herd of the last free roaming black rhino on the planet are, northwestern Namibia. Anywhere else you go to Africa, you see a rhino, it's in a national park or it's in a game farm. They're all fenced in. But in Namibia, you still have 300 of them that are free to roam. And you can go out with these rhino rangers and they'll track them from a distance to get pictures of them. And that's how part of how they're keeping watch on the rhinos, protecting them from poachers, working with local communities and stuff. But yeah, so you have these successful animals, polar bear, moose, rhinos. These are animals that have successfully evolved to our modern world, right? Or not our modern world, pre-modern. And they're facing extinction because of another species and what we're doing. And people talk about, well, the polar bears evolved to hunt seals on sea ice. And it's like, that's true. But they didn't do that in 50 years. They did that over the course of hundreds of thousands of years. A little fun fact, actually, polar bears are just basically tundra grizzlies. They can actually mate and have offspring. And increasingly, another fascinating climate change element, they're coming into contact with each other when they otherwise wouldn't have. The grizzly bears are moving into polar bear territory because that habitat is expanding. And so there's conflict and mating, and sounds like a reality show. And that's one of the theories, is that eventually, if we really don't get our act together, polar bears will get absorbed into the grizzly bear population and just disappear that way. But so here's the moose range. Again, you can see just northern fringes of Minnesota, Wisconsin, Michigan, and then the polar bear range on the right. And again, just illustrating how, let's see if I can do the laser again, where moose are in Minnesota and where western Hudson Bay polar bears are, they're on the fringes of their habitat. So little changes are going to be a big deal. Whereas if you're a polar bear up here, in Greenland, you're fine for a while. Life is good. In fact, some bizarre short-term effects. Oh, Svalbard's not on this map. Polar bears have been having some boom years for eating in Svalbard because the sea ice is forming so late that it's smooth ice. Whereas when sea ice forms, it gets all jagged and crashes together because it takes a lot more to freeze sea ice than freshwater. But seals use those ridges in the ice to give birth and protect their young. And now they're doing it on clear, flat ice. And the polar bear is like, really? Okay. Just literally walk over there and scoop them up. But that's obviously a short-term gain. And this is how Minnesota's moose habitat has changed. And the dark green area is where they had a primary range. And you can see huge swath of northern Minnesota historically, and then increasingly less and less. And so while, again, I think the light green would extend into northern Wisconsin and the UP Michigan, where there are moose, but their primary range is now diminished really just to northeastern Minnesota. And I always like to show this sign because this is in northwestern Minnesota, Karlstad, called itself the moose capital of the north, and there are no moose there anymore. And so in Churchill, you have a sign that's polar bear capital of the world. And someday, probably only 75 years from now, there won't be polar bears. And they'll still be there, but you're going to have to go a lot farther away. It'll be more expensive to get to them. So this is how moose get heat. So with polar bears, it's not that temperature bothers them so much. They can get overheated if it gets too hot in the summer too early, because they're super big. When they come out the ice, there's 90% body fat or something ridiculous, and they can literally boil to death if it gets hot. This happened with some Churchill polar bears last year because it hit 90 degrees in late June there, which is like if we hit 90 in March, which has never happened. They had an all-time June high temperature record, and that's right when the bears are coming off the ice. And so it's not a good time to have to be moving around in the heat. But moose, the temperature actually does affect them. This is a primary problem. In the summer, they overheat at between 59 and 68 degrees. That's how I always tell people I'm like a moose. Norwegians, if it's anything past 68, good luck trying to sleep in that. And then the winter, overheat at 23 to 32 degrees. And what happens is they become physically stressed. And what happens to any of us if we're stressed, if you're not sleeping enough, not eating well, worrying about too much stuff, you get sick, right? Same thing happens to moose, and that's why they're so affected by parasites, like these winter ticks. If you do, I don't recommend doing this before a meal, but like Google image, like moose calves are covered in ticks, and they literally die from anemia. Because winter ticks are thriving in these warm winters. So yeah, winter ticks, we're probably doing real good this winter in northern Minnesota. And so when you look at the future climate, these are based on several different of our climate models trying to predict what will happen in the future. So this is for the northeastern quadrant of Minnesota, so where there's moose habitat. Average winter temperature right now is 10.7 degrees, which is already 5 degrees warmer than it used to be. Between 2040 to 2080, not that far away, forecast is for it to warm to 15 degrees. By the end of the century, warming up to 17 or more degrees. And I put the reference in the south or the southwest. Can you tell I do weather? The lower left. Sorry, I was sick last week, so I'm still trying to find my bearings. 17.8 degrees is the average winter temperature for the Twin Cities. So by the end of the century, if we don't do more than we're doing now, northeastern Minnesota will have the Twin Cities winter climate. Well, no moose is going to live in that. Way too long of summers, way too short of winters, and not cold enough. But that's a rapid change, really, in 75 years to shift the climate that much. Already, just for reference, the Twin Cities, western Wisconsin climate is basically where Aiken, Minnesota is now. So we've already seen that kind of shift. Our modern climate is basically the Minnesota-Iowa border a century ago. So we're already seeing those. So all of a sudden you can start to see that welcome to Arkansas sign. Don't do it. Well, this is just a polar bear video. Oh yeah. Are you playing it? Oh, that's because you're fighting me on it. I was just going to play it. There's no sound or anything or there is, but we don't need. It's just a cool polar bear in Churchill. So this was mid-November this year. And what I want you to really look at is, what do you notice behind him? Water. 50 years ago, there should have been ice as far as you can see into Hudson Bay. We wouldn't have seen polar bears on land. They would have already been out on the ice. Yeah. We're in a tundra buggy. Don't worry, we're up high. But what's funny is this Churchill Northern Study Center where I bring people, they talk about when they give everybody a safety briefing, because everyone's like, well, can we go on a hike? And like, no hiking around here. All the doors are locked unless there's a fire alarm going off or something. Because this is probably 10, 15 years ago, a tourist from Germany who was there, and she just, after a couple days, it seems like, oh, they're just so cuddly, and they don't seem. So she saw one outside of the window of the research center where we stay, and she went out the door and was like going to go reach for it or get a closer look. And they like grabbed her by. They were like, "What are you doing, lady?" Yeah, but you just see, and but you kind of wonder, well, what would he do if we were down there? So remember, I asked that question of a polar bear biologist once, because it seems like sometimes they don't even care that you're there, and sometimes they are genuinely interested and want to smell, and or just they're very curious. Good predators are curious. They're constantly thinking, they're also like older brothers like me. Um, how can I mess up with my sister today? But that keeps you on your feet. And so I asked him, so realistically, let's say somebody fell out of the tundra buggy. What would the polar bear do? What do you think? He's like, you honestly have no idea. He might ignore it. He might run away scared just from what is this commotion, or he might be on her so fast that you wouldn't know what happened. At the study center, they actually had one of their mechanics was attacked by a polar bear fixing a snowmobile once, like scalped him. Yeah. So this is the Western Hudson Bay polar bear population specifically, which is what we see in Churchill, one of 20, again, polar bear populations. And this is a headline from just a few years ago. So they do a survey. Every 5 years, the results come out, because you can imagine it's not easy to count polar bears. You got to do it by air and satellite. And actually, the University of Minnesota has been involved in like a computer program that can use satellite imagery to decipher a polar bear versus just a chunk of ice. Which one's moving or not. But so every 5 years they come out with their figure. And in 2022, the numbers came out for the 2016 to 21, and they had a 26% drop in the population in a 5-year period. And the way that happens is you're not reproducing cubs. The older ones obviously are going to die out. Cubs just can't survive. And if you're not replacing the population, you got a problem. It's just a smorgasbord. It's nature, but it's a bloodbath. But again, this shows like through decades, you can see how that season's getting shorter and shorter. And the more time bears spend on land, the harder it is. And if you're an adult, they can survive it. The cubs, those 1 or 2 year olds, they can't. This year, anything that was born, which might not have been because it was such a bad fall, they would have done well this spring and summer. But the year before, there were almost no cubs that survived because it was 2022 into 2023 was a really bad season where the ice went out early last summer and then developed really late this November. So everybody was really worried about what would happen this winter. So this was a godsend that they had this late ice. But how much longer can they juggle this? If you give me one out of 5 good years, maybe I can hang on. It's just not going to be sustainable. Uh-oh. I think it's stuck again. Oh, there we go. Okay. So, and specifically, this is how it affects the polar bear population. Polar bears will start mating in the spring, March or April, and the female then she will have a delayed implantation. The embryo won't implant unless she consumes enough calories. So she will try to eat like crazy in that May-June period, and if she doesn't basically put on enough calories, that pregnancy won't stick. Or she might give birth, but those cubs won't survive because she won't have enough calories to produce enough milk for them. But if it's successful, she'll start digging dens. In Churchill, they do it in the dirt and mud in October, November. In Svalbard, they do it into ice and leftover snowdrifts in the higher Arctic. And then she will give birth around Christmas or New Year's Day to a little thing that looks like a little pink rat that can fit in your hand. And then they nurse on her in the den until March. And then when they come out all cute and fuzzy, like Coca-Cola wants you to think, and they also think that penguins and polar bears live together. They've been sucking on her milk for 2-3 months to get to that point. But when they're born, they're just little fit in your hand. But that means when all the juveniles and the adults get to go out as soon as the ice forms in increasingly later November and some years December, like this year, she's not eating until March. So she's having to not eat, and she's having to provide enough calories they give birth to litters. So when you only see one cub, that means for sure one died, sometimes two. They will give birth to 2 or 3 at a time. So it's, and many times not even one of the litter will survive. But so then she comes out in March and April, and she's trying to deal with these kids. Can you imagine? But she also has to she only has 2 months to eat, and you have this dead weight literally behind you. Like, okay, come on, guys. And they want to play, and you're like trying to eat, trying to survive. So that's why I like the best moms. I'm like, they have to eat way more. They have to hunt way more. They're literally providing. I mean, we all know moms are great, at least in the mammal world, I think. But like polar bear moms, come on. And then males will try to kill her cub if they come around, and especially if it's a late, like this last fall where everybody's hungry and she sees a mom with a cub, she will or an adult male will try to kill that. I have a book that has this picture of just a polar bear cub skull and then a bloody spine. It's really gruesome, but those kind of things are going to happen more when a population's stressed. Okay. Oh my gosh, I timed this perfectly. Anyway, just another ode to polar bear moms. So, and then I would say, so this isn't official yet, but I am this winter or this November, I'm not leading a group to Churchill because I'm going to be in Antarctica. I know. Boo. This is a trip that was supposed to happen in January 2021, but thanks, pandemic. So anyway, I want to do it again next November. I don't know, pricing. I'm just really guessing there. But you can go to this is the website for last year's trip, so you can get an idea of what an itinerary is like and what's included or not included. So if you just screenshot that or get it from somebody, you can check that out. But it's a place that I would like to get to at least every other year because it's fascinating just to see. It's so variable, the area. It's like Minnesota. Both places sit in the middle of the continent and have this extreme variability. Churchill's the only place in the subarctic that regularly does hit 90 degrees. Like, it's unusual for it to happen in June, but usually in late July or August, every few years, they do hit 90 there. Whereas the North Pole, at least yet, that doesn't happen. Or in Svalbard, places that are surrounded by cold water. But also, of course, Churchill can have the worst wintry conditions imaginable. So no complaining this winter. And I want people to embrace, we hopefully will have an almost normal winter. I will say that I used to just drone about winter and going to the Arctic many times and seeing its unique beauty, and going to Churchill has made me totally change my mindset and appreciate cold, even when it's a crappy April, where you're like, come on, embrace it. Those are less and less frequent. So, yeah. Thank you. Any questions? No? Perfect. Oh. What do you think first about any of them? Yeah. Well, what I tell people is sort of a philosophical answer, because everybody knows all the, green energy, blah blah blah, compost, etc. But I mean, those are things that you can do in a local community. I don't know if River Falls has a compost. Do they? Good for you guys. No, wait. Oh, yeah, for food waste. So like that's something that local people can say, hey, we want this. So like in Minneapolis, we have an opt-in. It's not for everybody, but you can request it and compost. And those are little things, of course. But I tell people we need to change our whole human mindset. First of all, we need to like determine what's truth and not truth again, because like science is under an attack because there's a war on what is truth. Like we can't even agree like that's black and that's white. Well, I don't know. You might be what? Anyway, so that like let's value truth again in science, and like our doctors and medical people that have taken a lot of crap the last few years. And but also there's actually a really cool open letter that happened at the beginning of the pandemic, and it was from a group of climate scientists to doctors. It's like, now we've been dealing with for 30 years. People are denying everything we say. They don't care, although climate deniers haven't tried to drink bleach. But oh no, they have actually. Yeah. Anyway, so we got to change our mindset from humanity. We're in this sort of colonial mindset of always trying to make everything better and progress, and we're going to do this, and we need to. Jane Goodall, who I've been lucky enough to meet and interview, she has this great. We have to stop thinking that we're apart from the earth, but we are a part of it. And the sooner we figure that out, the better, because Earth doesn't need us. Whatever we do to it, it will move on. We might wipe out most of the species, but there'll be some sluggy snail worm thing that survives and becomes the next whatever. It will survive, but we need Earth. And I mean, obviously, I'm not going to jump too much more into politics, but, voting matters, and in local elections more than anything. Yeah. Not that I don't think anybody in this crowd is going to stay home on election day. I'm just going to guess. I'm going to be in Africa, so I'm voting early, like next week, so that it's for sure, in case I get hit by a bus or something. They still count your vote then, right? Yeah. Okay. See, that's why you got to do it. That's why you got to do it. That's what like Jimmy Carter. I was lucky enough to meet and have dinner with several years ago, and he's a friend of mine is good friends with the Carters, and I keep asking like, well, how's he doing? He's been in hospice for 18 months or something, and physically he's really dwindling, but he's mentally, he's so involved in paying attention to everything, and he really wanted to hang on for the election is kind of his thing, and I'm guessing he's stubborn enough to do so. And I don't know what about voting early in Georgia. I think they're trying to make it less easy to vote. But any other questions? Yeah. I think we're going to have a close to normal winter. When I say normal in meteorology and climatology means the modern 30-year average. So what winter looks to us over the last 30 years? Normal snowfall, probably normal temperatures, not last winter, like I said, is not the new normal yet. That is extreme. Hopefully we don't see that again. But your kids or grandkids might again, and more frequently if we keep turning the knobs. But yeah, I'm hoping. My cross country skis sat in my basement all winter, and I just felt, guilty with nothing to do, no snow to shovel, or, what do I do? What do you do? Yes, sir. Oh, that's a good question. Because so what's interesting, the Arctic isn't a continent, right? It becomes kind of a continent in the winter when ice connects North America, Asia, Europe all together. So the Arctic is changing super fast, but that's a geographical area. And Antarctica is almost so big that it's hard to say, this is happening in Antarctica without saying, well, but here and here and there and there. So like where most people go to, where I'll be in January, is the Western Peninsula. And again, to fit into this theme, that's the fringe of the Antarctic climate and ecosystem. That's why there's so much life there. Where you have seasonal sea ice, that's where you get the different plankton to develop, and then the fish feed that, and the seals and the whales all come into that area. Same thing in the Arctic, but then you have the polar bears on the top of that whole food chain. So it depends on ice that comes and goes. Not like you won't see polar bears unless they're crossing the North Pole, because it's not seasonal ice yet. It might get there sometime in the future, but so far there isn't going to be seals in the middle of an ice field that never comes or goes. So it's hard to pinpoint one continent. I think Africa, even each continent has their own things. I think Africa is really a problem because it's so much of it's arid already, and we're seeing an increased desertification. So like Namibia, the black rhinos, it's a place that's dry, but then they're going in places like where these black rhinos live, where until 2018's drought broke, they had 5 years where it didn't rain at all. And that gets to be, it's already to the point where you go there and you see this big animal, a black rhino, and there's like a little scrubby bush there and another one a quarter mile away. And you're like, how in the hell do you survive here? Like the evolution is incredible, and we're pushing them to the brink because, okay, well, I give up, uncle. No rain in 5 years. That's a little too much. And because there's so many people in Africa and it's already a developing continent as a whole, I think that's one that's really vulnerable. So it depends upon what we measure as vulnerable. Like Canada is one of the fastest warming countries in the planet because it has so much Arctic territory, but it's a wealthy country that, you're not going to see dead people laying all over in Canada, I hope. But whole Inuit communities are disappearing as the permafrost melts. And I was reading something interesting recently about archaeologists are scrambling to try to find as many Inuit artifacts as they can because they're getting washed away. Things that nobody's ever seen, and they're just going to be gone because with the permafrost melting and these increasing storms. Or tonight, I haven't looked in a little while, but Hurricane Helene, another rapid intensifying hurricane. There's been a 72% increase in hurricanes that rapidly intensify. So that's one of the interesting things about future climate change as far as the hurricanes. The models and studies seem to show that we won't necessarily have more hurricanes, but they're going to be more powerful and that they're forming more quickly. On Monday, Helene was a blob of Minnesota thunderstorms, and now it's a category 3 storm and could be category 4 before is it 4 now? Oh God. Yeah. Another reason not to live in Florida. Oh yeah. I'll start over here. Well, I think we should all invest in Minnesota and Wisconsin real estate because people are going to be coming here. I don't know. I don't know. I haven't thought about that. 20 years isn't that far down the road. And that'll be about the time I'll be, in theory, retiring, if there's anything left of that. I don't know. Like in traveling, two people ask, what's a favorite place? I'm like, I literally have loved everywhere I've been to. And you can't compare a Arctic to Namibia. These are different places. I really love Africa, though. There's something special about that continent where you do feel like, you can tell, like, this is where it all began. Yeah. It's a long trip back to Minnesota. Yes.
Read that the Gulf Stream feeds warm water to the northern European areas. Quick collapse.
Yeah. Yeah. That's one of the things that is predicted in future modeling scenarios is that the Gulf Stream, for those who don't know, it's a stream of warm water that literally bounces off of the mid-Atlantic US and then shoots towards Europe, and that keeps Europe way warmer than it otherwise would be. So like Norway, if you look at the latitude of Norway, it's Alaska, but it's way warmer than Alaska. And if you look at Minnesota, we're the latitude of the northern part of Italy. Well, there are no Mediterranean cruises coming in this area. All because we're in the middle of the continent. So Europe is kept way warmer. And the idea is that as we continue to rapidly melt the Greenland ice sheet, you're adding that fresh water, it changes the salinity. And so you'd have warm and cold water streams, but salt water alters that chemistry so that actually cold water can float over warmer water when it's fresh, and that will subdue the jet stream. And so in a short-term scenario, Europe would get colder, but that probably eventually would run out. Once the ice all melts in Greenland, then the process will probably get back. And that's why, climate's complicated. Like I say, February and April are interesting months in this region that are actually trending colder. And you kind of just anecdotally like, yeah, we seem to be having more of these bizarre, like 2021, I was teaching middle schooler science. Any teachers here? And we're not worthy. I did it for half a year and I was like, oh my God. And these were good kids. And I was teaching all climate change and it gave me hope in the world, but I needed a nap. But I remember because that February we had that 10-day stretch of sub-zero temperatures, which is super freaky. And people are like, oh, see, we don't need to worry. Well, that's less and less frequent. And the reason that's happening is because we've screwed up the jet stream. And that air, which belongs in the Arctic, is 10 degrees warmer than it should be. So I know it sucks here or when it gets to Texas, but it's supposed to be up there. And that it's already 10 degrees warmer than it should have been. So, yes. Oh, yeah. You got UW-Madison is one of the best in the country. So you don't have to go too far. St. Cloud State I went to is a good one, smaller school. Madison has a big program, and Madison is actually a world leader in like satellite and tropical meteorology. Go figure. far from the oceans, but thanks to satellites. So you got a lot of good options. And actually in the region we do, Iowa State is a really great program too. Yeah. Good. Study hard math. Learn to love math if you don't already. Do you love math? You got time. I didn't in eighth. I failed 8th grade algebra and then realized that, I need this for meteorology. And then I only ever got A's ever since. So, because you got to take a lot of math in college, calculus and stuff. So take as much math as you can when it's offered. Now kids have like so many options in schools, especially probably like a River Falls school. I bet you have like actual options in what you can get, especially once you get into high school and stuff. So take advantage of those. All the math and science you can. And I think there's more over here. No? Yes, sir. Simple terms.
Equivalent to or equal to an issue of climate change.
Yep. Absolutely. Our summers. So while July and August aren't getting necessarily hotter in terms of the average temperature, our summer, first of all, I said they're getting longer. June's becoming an extension more and more of July, and September, like this year, is another August. But it's getting much more humid. Dew points are increasing. That's a measurable trend, even when they adjust for what we call corn sweat. So like when the wind comes out of Iowa, or we have those vast cornfields, but dew points are increasing. So our heat index values are increasing because you're increasing the dew point. So, and every degree Fahrenheit of warming adds 3 or 4% of water vapor to the atmosphere. So as we warm the atmosphere, we allow it to hold more water. It's the reason we don't have thunderstorms. Well, normally in the winter you can get thunder snow, but easier to get a thunderstorm because you get a bigger cloud made of more water in the summer than in the winter. But as you increase the temperature, you allow the air to hold more water, the oceans evaporate more, our lakes evaporate more. And so we're getting more of these torrential rainfalls that we get. 4-inch rainfalls used to be a big deal. Now it's, somewhere in the region gets a 4-inch rainfall every summer for sure. It used to be like a once in a 200-year thing. So more extreme rains because, you're only adding percentages, 3, 6, 10% of water vapor to the atmosphere. A storm condenses all that into one. So it's not just 3%, you get a lot. And that's part of what plays into hurricanes. Warming the oceans, there's more evaporation, there's more energy from the warmer water, and you're getting more intense rainfalls in these storms. So, we always make a big deal about the wind, but it's the torrential rainfall that really is a big problem in these tropical storms. And a 20-foot storm surge. But that's mostly because of Florida, but also rising sea levels. Yes. I don't know about thunderstorms, but one thing I've noticed, and again, I haven't seen any research on this, but anecdotally as a forecaster and talking with other people who forecasted, Minnesota, Wisconsin weather for decades, that there are certain scenarios where our models are less and less reliable. They don't know how to handle it. And it's usually going to be in a more extreme scenario, potentially like a storm system. So one of the things, because it's still cold enough most of the time, even in our warming winters, that we're going to see more snow than rain, right? So our snowfall is actually increasing, to go back to your point, because we're increasing the amount of water vapor. There's more water to make snow. So snowfall has increased by like 10% over the last 30 years. And so but if you're a skier, you're like, awesome. It's like, no, because it's not reliable, because then it'll be 50 degrees, melt it all, turn to ice, and then you'll get a 2-inch rainfall. So was it not this January, the January before, that was a cold January, 2022, 2023. But remember, we had like 2 1-inch rainfall events in January. That had never happened. To get an inch of rainfall in January is almost unheard of, but to have 2 of them, and it was but we still had below zero temperatures, but just this up and down extreme. And so more of those things, that's because some of our models are kind of adjusted to climate. They're statistical models as well as the dynamic models, not to get super nerdy, but so they rely on those 30-year averages. Well, you can throw a 30-year average away. Like our summers now, again, even though they're not hot, one of the alarming things about summers is they're consistently above normal now, whereas it's something like 16 of the last 20 summers have all been above the 30-year average. Whereas winters are still almost like 55 to 45% warmer versus cold, because there's more variability in winter, because in the Arctic it's still dark for 3 to 6 months. So you still get cold air to form, the ice forms, you're going to get snow. But there's more variability that can happen in winter. A lot of things can influence our pattern, whereas in the summer, the primary influence of everything in the Northern Hemisphere is the sun. So, yes. One more question, then I got to put my hair in curlers and go to bed. 2 parts? Oh, boy. Yeah. Yeah. Not climate models, but like forecast models. Yeah. And people, it's kind of fun because meteorologists when I started in TV weather 20 years ago, you were told not to get technical, that people didn't want to hear. I'm like, I don't think so. I think they actually want to nerd out a little. If you're watching the weather, it's not like I'm dealing with somebody who never watched, cares about anything. Anyway, but now everybody talks to them, so everybody knows the European, the Canadian, the American model, and they each have their strengths and weaknesses because it's the power of the computing. So the most accurate model is the European model, but it only forecasts for a shorter period of time and updates less frequently. So and we actually have several American models, but there's one in particular that most meteorologists refer to. It covers 16 days, for example, versus a 10-day forecast. Well, that's a lot more computing power spread out, whereas the European model is much more confined in terms of time, and so there's just more. So the best way to explain it is, one of my professors once said, the Europeans put all their resources into their one European model, but in the US alone, we have 10 different operational models that are of a similar, that forecast temperatures and precipitation, those day-to-day weather scenarios. So we have more to choose from, which actually makes it even more maybe stressful, because like 10 different scenarios, it's sort of like 10 different meteorologists, you're going to get 10 different forecasts. What's the second part? Oh, okay. Let's say I give long answers. All right. I appreciate it, everybody. But yeah, if you have any questions, email me. I'm happy to answer any weather, or even people are like, hey, can you tell me what the temperature was on June 3rd? River Falls, because of the university, actually has a pretty good, I think almost 90-year consistent temperature and precipitation record, whereas not every community does. That's why we always refer to the Minneapolis-St. Paul International Airport. Everyone says, well, nobody lives at the airport. Okay. Which is true. Unless you missed your flight.